Okay, guys, we have three things to look at. Working agent paths requested, circuits, and we'll look at acid and base. So the first question that we have that you guys have done, and it said it's quite easy. A small block of mass 0.4 kilogram is released from rest. You see, once I start reading that, I like to start analyzing quickly. I know that my velocity at this point is 0, which is 0.8 meters vertically above the ground. It takes the block 3 seconds to slide down from point A to E. Oh, so the entire thing is what? A to E, 3 seconds. All right, where it comes to rest again, they told me it's coming to rest. Velocity here is also 0. The length of the track from A to E is 8.1. Okay, they didn't put that there. Let me put that. 8.1. So right from here to here is 8.1 meters. That might come in handy later. 8.1 meters. Beautiful. Okay. Point D is 0.3 meters above the ground. The surface of A to D is frictionless. A to D, frictionless. Beautiful. D to E have a rough surface. Okay. Ignore the effect of friction. State the principle of conservation of mechanical energy. What's your answer? Don't whisper. Don't whisper. In an isolated what? System. Talk to me. Go on, Sitley. You are the one here, so you are the one I can punish. Yes? The total mechanical energy is conserved. I like the word conserved. Beautiful. We're done. Is kinetic energy at point B as the same as point C? Write only yes or no. Kinetic energy at point B. Guys, I want to get a yes or no from you. What do you think? Kinetic energy at point B and C. You said no, and you have a follow-up. Please give me 5.2 and 5.3. I need answers. All right, Sia, you're not giving me a reason. Sia, they said kinetic energy, not mechanical, is kinetic energy conserved. Yeah, what was your reason against it, Lee? Your reason is say, wow, what a reason. Okay, my answer is yes. It is conserved. And 3, it is an isolated what? System. That is, there is no friction, no applied, and no tension. It's an isolated system. So mechanical, look, we're saying the mechanical energy at point B, and it's not just the fact that, in fact, give you a reason, it is 2 marks. Isolated system and horizontal surface. If you just say isolated system alone, I would disagree. And horizontal plane, which means there is no there's no potential energy. So it's not enough to say isolated system. It is important to bring in the fact that it's horizontal. It is horizontal. I hope that makes sense. Because we're saying, check, Mechanical energy at this point is the same as this point, is the same as that point, is the same as that point. But B and C do not have potential energy. Potential energy here is 0 and is 0. So 2 points. Isolated system and horizontal plane. Those 2 points are important. If you just say isolated system, this and this, it's an isolated system. But the mechanical energy, yes, the same. Kinetic is not the same. All right. Use energy principles to calculate the speed of the block as it reaches point D. Okay. What I would simply do here, what would you do? Because look, mechanical energy at point A is the same as the mechanical energy at point D. So I could use work done by non-conservative equals to change in kinetic plus change in... Can you please tell me your answers before I start calculating? Tell me your answers. Just pop your answers in quickly as fast as possible. Three comma 13. Can we share answers, please? Google also has 3,13 meters per second. Wow, you guys have a party. You guys were communicating or something. $3,13. Who is also getting that? Venusia, all right. Emmanuel, oh, you guys are getting that. It's my turn to see if I'm going to get that now. All right, because it's an isolated system, why are you smiling? Because it's an isolated system, I'll say 0 equals to what? Half m. Sitler, if I don't have it, you're all wrong, right? Yeah, I must have that answer. If I have it, then you guys are correct. Okay, let's check. 0, what is the mass again? 0,4. What are we looking for? Final velocity, right? What's our initial? Our initial is 0 plus 0,4. What is g? Now, what is the final height? 0,3 minus 0,8. Is that what you did? The initial height at point A is 0,8, while the final height is 0,3. Okay, I'm going to put this in a calculator. I know probably you guys did not use my own formula, but that is you. All right. Let's do this together. This would give me 0,2. All right. Do you want to put this in a calculator for me quickly? Negative? You sure? All right. Negative 0,5. And what will this give me? 0,2 VF squared. So if I move that, I have 0,5 equals to 0,2 VF squared. Let's divide both sides and find the square root. Square root of 5 over 2. What? Okay, what's your answer? Redeem yourself quickly. Negative 1,96. Okay, quickly now. 1,96 divided by 0,2, and then you find the square root for me. Your smile. 3,13 meters per second. All right, everybody, thank you so much for those lovely, lovely answers. Thank you. I really appreciate that. Now we have one more question. Yes, quickly, let's take your questions. Emmanuel. Hi, Emmanuel, talk to me quickly.
But I got the right answer there.
Yep.
But I used the one of image initial equals to image final code. And you said that the mechanical energy at A must be equal to the mechanical energy at B, right?
All right, Emmanuel, let me show you something. That formula is absolutely correct, okay? But let me show you the connection between what I did and what you're talking about. This is what you did. You said what? EMEC at point A is the same as what? EMEC at point D, right?
Yes.
So it is EK, let's call it initial, right? Plus EP, initial. Do we agree? Because mechanical energy is the sum of kinetic and potential. Is that fine?
Yes, sir.
EK final plus EP what? Final. That's the formula you used. All right, check what I did. I want to show you the connection. I said WNC equals to change in EK plus change in what? EP. And because it's an isolated system, that is 0. So what is change? It is EK final minus what? EK initial plus what? EP final minus EP what? Initial. Can I move the initials to one side? That negative EK initial, what will it be? Are you seeing where I'm going?
Oh, yes, you can.
Beautiful. This was actually an exam question a long time ago. The examiner said, use work done by non-conservative to prove that mechanical energy is conserved in an isolated system.
All right, sir. So, and also just one quick question, sir.
No problem.
When do you use WNC exactly? Because I get a bit confused on when to use it.
Everywhere.
So,
Everywhere. This is what you must just need. This is what just you need to take note. If the system is isolated, then WNC equals to what? 0.
0.
Yep. And if otherwise, your WNC should be work done by what? Friction plus work done by applied force plus work done by what? Tension. So you can, every time they say work, use energy principles, you can use that.
Thank you so much.
You are most welcome. That's why we're revising. All right, guys, we have one more question, and I'll give you 5 minutes. The distance D and E is 3 meters. Use energy principles to calculate the magnitude of the frictional force acting on this block. All right, DE, I'll take you back to the exam question. 3 meters. The question says we should find the frictional force. Quickly, we have 5 minutes. That's the last part of the question. Don't ask me to go back. There's nothing to go back to that other page to. All right. So I'm not going back. We are looking for frictional force if DE is 3 meters. Can I get answers? What's your answer? Please share those answers. I'd love to hear from you. Remember? Let's start with Sitley here. Sitley, don't worry, just share your answer. Huh? You are the class. Guys, I'm waiting. Sitley said we should start with you all. She wants to confirm if you guys are correct. That's what you said, my child. That you want to check if their answers are correct. You don't trust those guys. Aribo, that's what you said. Huh? So are you saying I'm lying? Exactly. Exactly my point. Am I lying? No. A little bit of dishonesty. Guys, can I get answers, please? All right, 0.65.
Okay, yeah, my answer is 0.65.
Itumeleng says, Sitley, in you we trust. Thank you, Itumeleng, for the vote of confidence. Okay, I'm seeing, all right, there's a lot of 0.65 coming in. This question is actually not a hectic one. All right, let's see. So, what do we know? We know the velocity at D. Emmanuel, are you okay? We know the velocity at D, and we know the velocity at E. And we know that there's only one force acting. So, if I were to draw a free body diagram quickly, which could help me, what would you notice? There's only one force acting, which is the force of friction. And it must be acting what? In that direction. So I know my velocity here as, what was our answer? 3,13. And the final velocity here is what? 0. Energy principles. WNC equals to what? Change in kinetic plus change in potential. What non-conservative force do I have now? Friction. So friction delta X cos theta is half mvf squared minus vi squared plus mg h final minus what? I just like this formula. For me, I think it's just very straightforward. I'm looking for friction. Delta x, we're told, is 3, right? Friction is always cos 180 degrees. Half, what is the mass? 0,4. What is the final velocity? 0 squared. 3,13 squared plus, what is the mass again? 0,4, 9,8. What is the final height? 0,3. What's the initial height? 0,3. I hope it makes sense. Height, check. If you look at the question, can you see? It's a horizontal ground there. And I'm done here by looking for my answer. Half, let's confirm, because I don't trust you people, the fact that you all are trusting one person. But the child said there's a bit of dishonesty. So I want to show her right now. She said, how can you say that? I have never taught you anything and I'm going to start teaching you wrong things. Because you said, all right, we have that. Then we divide by what? -3. Because cos 180 is -1 divided by -3. 0,65. And what's the unit? Newtons. Done. Are we okay, everybody? All right. So this is quite straightforward. We just follow things like this and we'll be good. All right. Let's go to this question. Oh, this one we did just now, right? Yep, I see a hand up.
So I'm sorry for this now. I went out and then came back. I have a question. Where did you get the 3 meters from?
It's given in the question. Yes, let me show you quickly. Let me do this. I want to recrop that question. I want to recrop this question quickly. So guys, this is what we're going to do throughout from now on as we go on, all right? There it is. On the wrong page again. All right, there we go. I don't know if it's visible enough for you to see.
Say thank you.
You saw it, right?
Yeah.
Okay, beautiful. All right, guys. Next thing, we quickly go to the electricity question. And I think there's an error somewhere there because I just saw an addendum right now in the messages that I received. This one is out now. This one is done. Okay. Please start. And this question, I'm going to remove it because I'll go through it later. They said there's an error there. That 7 marks question, which I would have really loved to see what the error is, but I'll check offline. So we're not going to answer that. It says do not, they shouldn't. I think there was an error. There's an addendum attached. All right. So, whoosh, I was happy that we're going to get some real questions. Now I'm sad. All right. Anyway, 2, 4, 3. Let's go. 7, 9. 6 minutes. Because one of them is just a definition. 6 minutes. Okay, tell me we have answers. Quickly, because of our time. Because Sikulele has asked us to look at the Gauteng one as well. So we're going to try to run. In the circuit diagram below, the battery has an EMF of 15 volts. You know, I like to write out my things. It helps me. Internal resistance of the battery. Oh, they gave us internal resistance. What is this? Easy question. Easy question. All right, V2, AB. State Ohm's law. We all know that, right? That what? The potential difference is directly proportional. All right, potential difference across a conductor is directly what? Proportional to current at what? Constant temperature. You know, normally I wouldn't write all of this, right? But I want us to start, checking our definitions again. Equivalent resistance of the external. What do you notice? The 7 and 6 are in parallel, are in series. So can I say, let's say R series, R7 plus R6, which will be 7 plus 6, and that's 13 ohms. The second series would be what? The 4 ohm resistor plus the 6 ohm resistor, which is 4 plus 6, and that gives us what? 10. So how many resistors do I have now? 2. So I can say R total will be, since there are 2 resistors in parallel, I can say product over sum, which will be what? 13 times 10 over 13 plus 10. What would that give us? Let's compare with yours. I know you didn't do it this way. 5,65. Is that what you got? Huh? What did you do? Come on, what did you do? Why would you need to do all of that? They said find the total equivalent resistance. They've already given you the values of all the resistance, so you don't need to find any more current. Check, that's what the question is saying. All right. I hope you guys are okay with that. Total current, easy. This one is very easy now. I into bracket R plus R. What's my EMF? 15. I do not know I. What is my total external? 5,65. What is the total internal? 0,45. Do you want to give me current I quickly? This question is so straightforward. No games. What's your answer? 2,46 amps. Let me see. Thumbs up, thumbs down. Let's see, guys. Anybody with a question here on this? We're good. Everybody all right? Beautiful. Okay, quickly let's run. The 4 ohms and the 6 ohm resistors alongside B are removed. All right, so we now remove the 4 and 6. Are you seeing that right? Okay. How will this change affect the V reading? Increase, decrease, or remain the same? Explain your answer. Quickly, guys, check. They said the V reading, which is the top. Quickly answer that for me. We remove the 4 and the 6. Let's answer. We remove the 4 and the 6. How will it affect the V? You have 2 minutes and 30 seconds to think. Yes, Tepang, talk to me.
So I was actually asking, was there no external control in this question?
Sorry? No, it's not marked. It's your paper, right?
Yes, sir.
Yes, it was removed.
Oh, okay.
You happy?
Okay, sir. Yeah.
I can see that you're smiling. You're like, oh, thank God. God, you're so awesome.
Yeah. Okay, thank you, sir.
All right. Okay, I have a hand up.
So, like, which 6 do they want removed? Is it
On B.
the 4?
On B, the one with the 4, the one at the bottom.
Oh, okay, thank you.
All right. Quickly, guys. All right, guys, whenever you see such questions, please answer your questions from the angle of resistance. I always emphasize that those questions require you to use this, if you remember, revive. That if my resistance, I have taught you this over and over again, if my total resistance increase, what will happen to current? Current will decrease. They are inversely what? Proportional. Now we use Ohm's law. If I decreases, lost volt will what? Decrease. And VE will increase. The other way, if this decreases, what happens? This will increase, and this will decrease. So if we remove the 4 and the 6, what happens? If you are not sure, come back to your value here. Check. The total resistance right now is what? 5,65. Now, if we remove this one, which is the 10, what happens to your total resistance? Can you see it increases? It's now 13. All right? I remember giving you lots of notes on this. So which one will be my answer here? The first one. Total resistance will increase. Current will decrease. Lost volt will decrease. External volt will increase. Please let me know if that makes sense. Total resistance will increase because we are removing resistors that are in parallel. All right, so that's my answer. All right, so I have answered 8.2 and 8.3 combined. My answer will be what? Increase. And it follows that what happens? Total resistance will what? Increase. Lost volt, VI, will increase. Right? No. Current, we missed current. Current will decrease. Lost volt will decrease. External volt will increase. Yes, there's a hand. Yes, quickly, talk to me. You have 2 hands, Emmanuel and Tepang.
So I understand like the resistance increasing and the current decrease. But I don't understand why the internal voltage decrease and the external voltage decrease.
What's your formula for lost volt? V internal. It is I multiplied by what? Small r. So your current has decreased. What happens to your V internal?
It will decrease.
Ohm's law, remember? Current and potential difference are directly what? Proportional. Now, why will your external increase? EMF is V internal plus V what? External. And this EMF is constant. Okay, they gave us 15. Check something. Let us say, oh, did we get the current? Let's do the whole calculation. What was the current? 2,46, right? So this is what? 2,46 times 0,45. Let's say we don't know the V external. Do you want to give me an answer here quickly? Let's do the maths. 2,46 plus times 0,45. What? Okay, 15 minus that.
So you get 13,893.
20? You said what?
13,893.
All right. 13,893. Let's now work the other one out. Now, when we remove the 4 and the 6, what is my total R? My new total R? 13 ohms. Is that okay? All right, 13 ohms. The R is still what? 0,45. Let's calculate current. E equals to I into R plus R. I want us to prove everything we've said. My EMF is the same, right? But my current will change. This is now 13. Please be fast. Give me current. Let's see if our current will decrease. Our current must be smaller than 2,46.
So you get oh no, sorry, ma'am. I realized my answer was wrong, so sorry.
All right, quickly. Huh? One comma 1, 2. Do you notice that my current has dropped? And that's what we said. Now, if current drops, what is the new lost volt? V internal. It is I multiplied by R. 1,12 times 0,45. What is your answer? 0,50. Now, what is, remember we said EMF is what? V external plus V what? Internal. 15. V external plus 0,5. What would be your answer? 14,95. Now compare 14,95 and 13,89. Are we okay, Manuel?
Yes, sir. Yes, thank you.
All right, so revive is the key to this question. Sepang, your hand was up a while ago.
Yes, sir. I didn't understand the revised thing.
But now?
But now I get it.
It makes sense, right?
Yes, sir.
If I were to give you a full statement, this is what we're saying. Let me give you a connection. Revive. R-I-V-I-V-E. These two are inversely proportional. These two are directly proportional because of Ohm's law. And this E is constant. That's what's going to affect that. If one decreases, the other one will increase. EMF is constant. So that's the relationship between those things there. All right. Let's see. Siklile is asking for the Gauteng electric circuit. I thought we'll look at, but let's see. You answer 8.4 for me quickly. Costing. This is grade 11. Check on your side, my screen is visible. Look for the correct crazy physics. Let's see, guys. I want to see if we can touch that acid and base one question, and secretly we'll try to, I'll just go through the Houghton question and possibly the acid and base here with you. I'll just take the honors of doing that because of time. I don't know if you guys are winning so far. So unit is in kilowatt hour. Let me just walk through this. Kilowatt hour, you see there, kilowatt hour. All right, so what is, let's see, how one light bulb, how much will it take us to run one light bulb? All right, so we take the power. Power is in watt. We must convert it to kilowatt by dividing by what? 1,000. All right. Times 8. What will this give us? Do you want to help me? 0.48 kilowatt hour. All right. 0.48. That is the unit of running electricity on one light bulb. All right. And what is the cost of one light bulb? They said it's 2 rand 55 cents multiplied by 0.48. What would that give us? 1 comma. Okay, let's see. I'm seeing something here. The cost of energy is 2 rand 55 cents per 1 kilowatt hour, right? How many 60 watt light bulb can we have for 8 hours per day if your budget for lighting is 250 per month? All right, so what have we done? First, we calculated the kilowatt hour for the light bulb. Unit is 0.48. To run one light bulb for all right, this would be for 8 hours. All right, this would be for 8 hours because this is what we said. Let me make it clear. We're saying for 8 hours we use what? 0.48 kilowatt hour. Is that okay? And the price for 1 kilowatt hour is 2 rand 55. So if I multiply that, I have 1 rand 224 per day. Now, how much will it cost me to run one light bulb for 1 month? Assume they are 30 days. For 1 month, what will I have? 1,224 multiplied by what? 30. What is your answer? 46,36,72. Now, at how many light bulbs that will I run? How many light bulbs? If a total I have is 250 divided by 36,72. 7. Give me it's in decimal. What's your answer in decimal? 6,81. So I cannot run 7. I have to run 6 light bulbs. You cannot round off a light bulb. A light bulb is not. So the correct answer will be 6 light bulbs. Because if I run 7 light bulbs, I'll go over my budget. Let me know if it makes sense, everybody. Let me know if it makes sense. A lovely question here. I love it. I love the dynamics. Bringing in maths and, So first we calculate for one light bulb for 8 hours per day. Then we calculate for 1 month. Then we divide in total. It's just a bit of maths lit here now. All right. We're good. Let's try to see this acid and base quickly. 23 marks. Secretary, if we cannot come back to your question, don't worry. I promise you we're going to look at it. But I want to make sure I balance both paper 1 and 2 in every session. Don't worry. I know you said you were traumatized. Relax. I got you. Okay. But I will advise now that you are not under pressure, try to look at it again. You might actually see the things that you didn't see during the exam, even without you going through the memo. All right, according to the balanced equation below, a dilute solution of HCl is used in titration against ammonia. Define the term hydrolysis. Come, give me an answer. Define hydrolysis. Our definitions, are they in place? Number 1, a reaction of salt with water. A reaction of salt with water. Number 2, will the final solution be acidic or basic? You know what's going to help you here? Identifying examples. And remember when I was taking you through acid and base, I told you if you don't know those examples of strong acid and strong base, it's going to come and bite us. So what do you know about hydrochloric acid? hydrochloric acid is a strong acid, while ammonia is a weak base. And I told you the strong will always win. So what type of salt am I forming? Acidic. So if you find this difficult right now, please tonight, go back to the notes I gave you. Just go look for it. Look for those examples. Read it. Tomorrow morning, rewrite those examples again. Of what? Strong acid, strong base, weak acid, and weak base. These are quick wins, quick marks that I need us to get. 7.1.3, hydrolysis. I remember giving you a system of dealing with writing this equation. I don't know if you remember. First one, I'll remind you, don't worry. To write this equation, this is what you do. Identify the type of salt. Like we've done, we said it's acidic. Is that okay? Number 2, break down the salt or ionize the salt. Ionize the salt. Number 3, react the weak one. React the weak ion with water. If it is acidic, you are going to form ammonium ion. If it is basic, you are going to form hydroxide ion. Take note, it's free 3 marks that I need you to get. So when I say ionize, this is what I mean. Break it down. NH4 plus and what? Cl minus. Already we've identified the type of salt by saying strong and weak would give us what? Acidic salt. Number 2, ionize the salt. Break it down into ions. Number 3, which one is the weak? Remember, we said ammonia is the weak, right? So, which one is going to be the weak ion? Ammonium ion. Because it's come from the weak side. Make sense? Take that and react it with what? Water. So, NH4 plus what? H2O. I want you to be clever. Since you said it's going to form an acid, it's an acidic salt. So what should I be having? H3O. Can you see? If I take this here, what do I have? I have H3O plus. Then I've removed that and I have that. I'm done. 3 marks in the bag. Follow that step. Identify the type of salt. Ionize the salt. All right? React this weak ion with water. If it's an acidic salt, which comes from identification, ammonium ion. If it's a weak salt, which comes from identification as well, you form hydroxide what? Ion. So this tells me that it is what? Remember, what is an acid? A substance that ionizes in water to produce hydronium what? Ion. And that's the definition there. Arrhenius. Sweet. Okay. And then, what did I do? 7.2. For the above titration, 25 cm cube of ammonia is titrated with 40 cm cube of hydrochloric acid. Do you notice I have already answered 7.2.1? Is it a strong or a weak? Strong acid. Why is it a strong acid? The examiner is simply asking you to define a strong acid. What is a strong acid? Huh? Sure. Sidley. It ionizes in water completely. Have you forgotten? You cram pass and forget. So don't roll your eyes. Huh? It ionizes in water completely. Itumeleng. Can you see what Sitle is doing here? Completely to form a high concentration. I need these definitions. Of what? Hydronium ions. So they are basic, and that's why it's 2 marks. Remember, your definition is also 2 marks. Write down the name of the indicator again. Ooh, all of this is just going back to, do you know a strong acid and a weak base? Do you remember my indicator? My beautiful princess? Don't even start with me, child. I said indicators. What do you have? My beautiful princess. MBP. What is this? Methyl orange. What is this? Bromothiamyl blue. And what is this? Phenolphthalein. And it's always arranged as acid, neutral, and basic. And I did say, when do you use the one that is acidic? When you're going to form an acidic salt. So when do we form an acidic salt? When we have what? A strong acid and a weak base. Remember, the strong one would win, so the salt is acidic. When do we have it as neutral? Strong acid plus strong base, weak acid plus weak base. So this is a good crash course. When do we have a basic? When we have what? A weak acid plus a strong what? Base. And I remember I also gave you the color indicators. My beautiful princess. I give it the color chart. Red, orange, yellow, yellow, green, blue, colorless, light pink, no, I think this one is pink, colorless, light pink, and colorless. The last one, I'm just going to confirm. But that's the color. And if you notice the color wheel, I did say use your Roy Beef. R-O-Y. Can you see it follows? All right. So please, these are contents that I need us to quickly get into place. Yeah, I knew something was wrong. I mixed this one. Yeah, it's colorless, light pink, and pink. All right. So take note of that. And you use the phenol. You see, color of phenolphthalein is P. I use that to guide myself. Okay. Quickly, let's answer this stoichiometry, and then we can move on. So in this case, thank you, Tumeling. What are we using? Tumeling says methyl orange. Makes sense now, right? So what indicator are we using? Methyl orange. Why? Our salt is acidic. So write down the name of the most suitable. It is methyl orange. I actually answered all of that. Explain your choice. All right. We have what? An acidic salt. Our salt is acidic, but they said 2 marks. So why am I choosing that? I'll tell them that methyl orange is acidic, and we have an acidic salt. So it's best, it's in its domain. All right, it's an acidic pH. It has an acidic pH, so it works best in an acidic medium. Calculate the number of moles in, I think that's very easy. What do we know about the 25 cm cube? We have volume and we have concentration. Do you see that? Very straightforward, 3 marks. Let's get those 3 marks. Calculate the number of moles. What is your volume? Please remember your volume must be always converted to dm cube by dividing by 1,000. And the concentration is 0.1. Let's finish quickly here. Number of moles of ammonia. What's your formula? CV. 0.1 times 25 over 1,000. Is it 25 or 45? 25, so I'm correct. Okay, quickly, let's get this done. What's your answer? Zero comma 0025 moles per cubic what? Decimeter. We are done there. Now let's look at the last question quickly. 8 marks. Calculate the pH of the final solution. In fact, I did this before, I think last week. pH of the final solution if the concentration of the original HCl was what? 0.1. All right, quickly, what do we know about the HCl? So HCl, here, let me just quickly write all the information. HCl plus ammonia gave us ammonium chloride, right? What's the concentration here? 0.1. 0.1. Volume here is 40 dm cube. And volume here is, all right, they want the pH of the final solution. And I told you, here is what you do. Algorithm. First, write the formula for pH. Negative log of hydronium ion. Now, let's find the concentration. Equals to what? N over V. And this is going to be number of moles in excess. While this is going to be total volume. If you can see this, that's your 8 marks. Just that, 8 marks. But how do I get my excess? We're going to compare the number of moles. Examiner has already given me a chance to get this. What is the number of moles of hydrochloric acid? CV. 0.1 times 40 over 1,000. 0.004 moles. All right? So, I will then compare mole ratio. I see HCl to ammonia is 1:1. If I use 0, I see already that, let's see, what's the number of moles needed here? the number of moles of HCl needed. If I cross multiply, but what do I have? 0,004. So can I get the number of moles of HCl in excess? 0,004 minus 0,0025, 15 I think. So what is concentration? Number of moles. This is routine. That's why I'm moving very fast. It's routine. If you were in the last lesson that I did all of this. What is the volume? This one is 0,004, right? Wait, something is wrong here. Volume here is 0,025. So 40 plus 25 will be what? 65. Divide by 1,000. What's your answer? We're done with the 8 marks. It's routine. Please let's learn to do this particular acid and base. 0, moles per, and that's the concentration of the final. So pH equals to negative log, and remember, I'll put the 1. I just want to put the 1. Where is the 1 coming from? HCl is a monoprotic acid. If it's a diprotic, we'll put a 2 there. What's your answer? We're done. 8 marks in the bag. It's routine. It's routine. All right, guys. Let me know if there's any question. I know I was moving very fast, but I have done the algorithm on that side. pH of the final solution is negative log hydronium ion concentration. So you find your concentration by saying number of moles over volume, and the number of moles will be number of moles in excess over the total volume. Total volume means you add 40 plus 25 in this case. So total volume is 40 plus 25. So your job is to find the limiting reagent. And how do you find the limiting reagent? Find the number of moles of A, find the number of moles of B, compare the mole ratio, see where you have excess and where you have a shortage. All calculations must be done on limiting what? Reagent. So I see that my ammonia is limiting. How do I know? 0,0025 would require 0,0025, and I have 0,04 of the acid. So my acid is in excess. Please, let's look for questions on this final solution. Practice. Just nail this one in the box to say, okay, if they ask me pH of final solution, I think I got it. And you'll be getting 8 marks very fast. She is telling me, I wasn't there when you did acid and base. Okay, what? Say something. Aha, better. Better not say anything. Guys, we're out of time, but can I take 10 minutes? I want to help Phsc. I'm not okay not helping that Phsc. Can I? Do you want to take a picture of this? Phsc, let's just quickly look at it. Even if I don't do it, let's see if we can analyze it. Then you try. Let's see if we can analyze it. Then you try to. I won't be okay if there's a request and. All right, let me see. Open the paper. Oh, and I had it just now. She said the Gauteng one traumatized her. And Maybe some of us are here as well. How did you find this? I'm sure it was just this one that, because the 8.5 looks. Yes, talk to me quickly. There is a Tepang.
No, sir, but like when we come back, like, could you also do the 2024 and the what is these things, the acid, the chemistry part, the acid and base calculation, and also there's also another calculation in the 2024 one, the Gauteng one that had me ish. I don't know.
It had you.
There was this other one where it was like identify the element or something like that. Could you also please do that one?
Okay, please find. You have the.
It doesn't have to be today.
Sorry.
It doesn't have to be today, but like whenever you have time.
Okay, all right. No, we'll do it in the next session. Just you let me just identify the particular question so we can walk through together. All right. Okay, thank you for that. All right, look here. A battery with an unknown EMF. So we don't know the EMF. Internal resistance is 1 ohms. All right, it's connected to 3 resistors. All right, R1, R2, and R3. A light bulb. We have an ammeter, blah, 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 and all of those things. The resistance of the light bulb is 4 ohms. Oh, there, 4 ohms. And the resistance of 3, okay, we have 2R, R, and 6R. Okay, can I jump the definition of EMF? We're running. When switch S is closed, the current through the ammeter is 0,2. Is that written? Yes, beautiful. I would have written it there now. And the potential difference across R1 is 6 volts. Now, this is what you do in an exam. You go and write that information there. You want it visible at once. 6 volts. Okay. Write down the value of V2. Write down the value of V2. All right, look, what do you know about things like this? R1 and R2 are what? In series. What do we know? The current is the same. Remember, series are potential what? Dividers. It means current is the same. If you cannot do the write down, let me show you how you do it. Let's calculate the current in R1. V equals to what? IR. What is our V? 6. I do not know I. It's fine. But what is R? 2R. Make sense? So what is your I? 6 divided by what? 2. That would be what? 3 over R. This same current is the one flowing in what? R2. So V2 equals to what? I2 multiplied by what? R2. The examiner says we should find the V. Okay, so we're looking for V. What is your I? It is 3 over what? R. Are we there? Multiplied by what? What is your R2? Does that make sense? Do you see we are done? 3 volts. Even if you cannot do the write down, let's do it as a simple calculation. And it makes sense to me because it is half of it. If current is constant, voltage and resistance are directly what? Proportional. Number 2, write down the current through R2. Okay. Do you see that we have the current already? 3 over what? R. Because we don't know the value of what? R. Are we done there? Current is 3 over what? R. Calculate the resistance of R3. All right, let's see. What do we know? The total voltage here is 9 volts. And because this and this are connected in parallel, what do we know? Parallel are current what? Dividers. Make sense? It means potential difference is the same. It means the potential difference here is what? 9 volts. Do you notice I already have, let's see, is there anywhere they're telling us to calculate the value of R? I want to see something. All right. So, what are we looking for? The value of R3, right? Okay, check. What do we know? V3 equals to what? I3 multiplied by? Do we know V3? Now we know it's what? 9. Do we know I3? 0, 2. And what is R3? 6R. I don't know if you see that we're done already. What would that give us? 9 equals to 1, 2R. What is your R? What is the value of R? 9 divided by 1, 2? R is 7,5 ohms. So R3 is what? 6 times 7,5. Oh, we shouldn't have even gone out of that. We would have just gotten 6R there. What's your answer? 45. So by analysis, we're done. What are we looking for? The next question, EMF. What do we know? EMF is what? I into bracket R plus R. Can we get the total current? I think we can. Because already, do you notice now we know the value of R? What is R? 7,5. All right? So, what is my current? Do you notice we have our current? 3 over 7,5. What is your answer? 0,4. Now, if I have 0,4 in this line and I have 0,2 in this line, what's the total current? 0,6. Remember, it splits and is there a mistake? Because I know you, the way you look like that. So my current is what? 0,6. Do we know the total resistance? I'm sure we can get it. What is the total? We have 3R here. Let me get a colored one. We have 3R here, and we have 6R here. Total resistance. Let's go work it out. So you show all of these workings, though. Total resistance. Since there are two of them in parallel, 6R times 3R over what? 6R plus 3R. What will this give you? 6 times 3. 18R squared over 6 plus 3. 9R. What do you have? 2R. But what is R? 7,5. So total is what? 2 times 7,5, which gives us what? 15. I'm done there. Do I know my internal resistance? 1. Sikulile, talk to me.
Yeah, so I understand.
It was so easy, man.
You know,
You see that it's so easy, ne?
I think I got thrown off by the R's because I was seeing a lot of unknowns.
Nah,
So it threw me off.
just throw it together as R. It's algebra. What's your final answer here? 9, comma? Done. Good night, everybody. It was so easy, man. Good night, good night. Huh? I'm giving you stress. Unfortunately, I can only give you what I have. I don't have stress, so I cannot give you stress, child. Good night. Good night. Good night, everybody. Good night, Venusha.